The industry is moving towards standards-based technology, and industry leaders are helping the ecosystem contribute to open sourcing and open networks. But how does a theory of standards-based approach work in practice? TI now is talking with two people here at Mobile World Congress to give you a real-world use case putting standards-based technology to work. To my right is Sandra Rivera. She's the Director of Market Development. That's for the Communications, Storage, and Infrastructure Group at Intel. And next to her is Dor Schooler. He's the Vice President and General Manager of the Cloud Band Business Unit at alcatel-lucent. And panelists, welcome to the program.
Thank you.
Thanks for being here. It's a bit of a long introduction, so I hope I didn't stumble too many times. Thank you both for making it here at Mobile World Congress 2014 and being on our panel. It's quite timely, as there was an announcement made just yesterday between alcatel-lucent and Intel, and again, that's timely for us to be able to talk about it. Sandra, I'll start with you. What was that announcement about?
Well, it was an announcement about a pretty broad collaboration that we're very excited about in terms of moving the market forward to deploy standards-based virtualized server technology in the network, and what we call network function virtualization platforms and solutions. So Intel and alcatel-lucent, we're collaborating in three different areas. One is, of course, the virtual RAN, which we'll talk a bit more about, and kind of the benefits of virtualizing a baseband pool of assets, if you will, at the edge of the network. The second area is in the high-performance packet processing capability that we bring to the market that alcatel-lucent will leverage in terms of scaling out their platforms, particularly in their router portfolio. And then the third area, which is near and dear to Dor's heart, is in the cloud band management and orchestration platforms. And so a broad collaboration, getting to market more quickly, real solutions, and I'm sure Dor will talk about cloud band.
Anything to add about the announcement, Dor?
Yeah, I think what's unique about it is that we're really trying to accelerate the market adoption into NFV. And it would be a terrible shame if this whole thing, there's so much hype about NFV, right? I mean, a year ago it didn't exist, and now it's all everybody's talking about, especially in Mobile World Congress. But it could still, at the face of history, be seen as a science experiment that never went anywhere. And there are very real barriers to get it to adoption around operations, around how do you manage distributed clouds, because NFV is extremely distributed. How do you get performance up? And our goal is really to do two things. A, make sure it doesn't happen, right? It actually moves into production. And two is to remove as many barriers as we can to get this market accelerated and get it going out of the lab into the field and then into production. So we're very excited about that because I think it's the right place to collaborate on. We've been working on technological collaboration for a long time, but this is a lot more focused on getting the job done. Tactically, I think we have three areas that we're working with in the cloud band piece of the collaboration. We're working together with the ecosystem to expose a lot of the Intel technologies that are key to get performance up and to get deterministic performance. It's not just about throughput, it's also about deterministic performance. And today it's not very programmable, so there's great capabilities in the Intel chipset, but if a network function wants to use it, you actually need to go into the hypervisor and muck around and try to activate it, and that's not very scalable. And the promise of cloud is having everything programmable, everything done through abstraction layers at scale. So we're working together to make sure those things are exposed in OpenStack and in other open source projects to make it consumed not just by alcatel-lucent platforms or alcatel-lucent products, but for the entire industry. Then we're creating an acceleration lab, or a performance lab, where any network function can come in and think of getting their function to work on the cloud as like getting a car on the road. Then they go into our garage to tweak it and tune it, right? And really get it to be done at speed and at the right performance they're looking for. And we'll also do a bunch of things with customers to help remove the barriers and help customers move from the lab into production.
Sandra talked about part of the announcement yesterday being about cloud band that you talked about, but for our viewers that don't know what cloud band is, can you describe briefly what that is?
Sure, so cloud band is the platform for NFV. We started 3 years ago, before NFV happened. We used to call it Virtual Telco because there was no other term, but we've been at it for about 3 years. We just announced our second generation platform, and essentially we do two things. NFV is about creating lots of distributed data centers that become clouds and then managing them in a smart way on behalf of virtual network functions. So the two things we do is our cloud band node software stack which takes a rack in those distributed sites and turns it into a cloud with OpenStack or CloudStack, with SDN, where we use Nuage SDN, but we can definitely open there, and storage technologies, virtual storage technologies, and monitoring and alerting capabilities. So that's one piece. And the second piece is the cloud band management system that then knows how to manage all of those clouds. We call it a sky view, right? Because if you want to see lots of clouds, you need to look into the sky. And then optimize workloads. Which site do they need to go into? Maybe 2 tiers of an application need to sit in the same site because of east-west traffic and lots of latency considerations. Maybe pairs need to sit in different sites because you need better reliability. How do you stitch the network to make it happen? In each of the sites you have different security zones and availability zones, which are the right ones. So basically allow applications to capture the operational aspects, to deploy their application, their topology, their networking needs, and their KPIs or SLAs that they need from the infrastructure, and fully automate then the deployment so they can be deployed on multiple sites simultaneously, stitched together in the network, scale, heal, and be monitored in a completely automated and programmable way.
Sandra, what's this transition like for you to entertain this, I wouldn't say entertain actually, to put into practice this open approach, open networking, open sourcing, and work with companies like Alcatel-Lucent?
Yeah, so it's been very exciting for us, and I like how Dor touched on the fact that we've been at it for a number of years, right? Any big shift, paradigm shift, particularly in network architecture, takes about a decade, right? Even if you look at 2G and 3G and 4G, and now we're kind of on the precipice of already started talking about 5G, but it takes about a decade. And the good news is that we're not at day one of that transformation in the network. We did start probably in earnest somewhere around 5 years ago at this stage with Alcatel-Lucent in this particular platform, probably as far back as 3 years ago. And what we've concluded at this stage in terms of that shift is that all of the technical feasibility work to answer the question, can these workloads be effectively run on general purpose processing technology? I think that we can pretty much check that box and say, yeah, they can be done. I think that the bigger challenge now is how should it be deployed from an operationalization perspective, from a commercial viability perspective, from an overall, not just the total cost of ownership benefits and things that you will save money around from either a CapEx or OpEx, but what could you do now that you couldn't do before? Dor describes a distributed intelligent network of these clouds that are programmable in ways that the network was not programmable before. So for us, it's very exciting to see a lot of the capabilities that we bring to the market in terms of server leadership, virtualization leadership, cloud technologies, and business models leadership being applied to the network. It's not a copy exact. There are some very real-time latency and jitter types of issues that you need to address, particularly in the access network. There are huge performance considerations in the core of the network, but we certainly believe that we understand, and working with market leaders like Alcatel-Lucent, what applies, what needs to be tuned and optimized, and then what yet needs to be innovated, right, in terms of new capabilities that are specific to communications networks.
Dor, anytime we launch, or you launch a new technology, there's always that question of monetization. How do you monetize this new technology? Total cost of ownership is part of that conversation. How do you improve the percentage of TCO with Cloudband? Yeah.
So we're thinking of taking a Facebook WhatsApp approach of spending $19 billion with no way to monetize it inside. But no, I mean...
Well, you decided against that.
We decided against it. Frankly, the drivers for our customers are very, very clear. And that's what's making NFV, I think, so prominent in the show here, that we're not talking about 10% improvements. When you look at the triggers for our customers, you kind of need to look at the present way of doing things, right? And it takes 18 months to 3 years to deploy anything new in the telcos. Once it's running, if you want to add scale to that, it takes 9 months to the good guys, right, that really have their operations managed well. 18 months is the average in the industry. Huge amount of spare parts, because every network function has its own spare parts. Huge complexity in upgrades. I know upgrades is less sexy, but you know what? When you need to upgrade any network function to any new software drop, you need to go on site, have people on site, take it down for maintenance, migrate users off it, upgrade the software, migrate them back. That's creating a very, very complicated environment for our customers. It's why spend on carriers is about 20% on CapEx and 80% on OpEx. It's why it takes us a long time to react in the industry to market forces and the needs of our customers. So that is the driver. It's not so much on the CapEx savings, although they exist. It's about faster time to market, significant simplicity in the network that drives lower operational costs, lower amount of spares, and a common approach to manage their infrastructure, which then leads to various other savings and synergies between applications and a holistic view of the network as a whole.
As you talk about this process from, I guess, the trial stage to putting something into the commercial market, and I'll pose this to both of you if you'd like, Dor or Sandra, can you give me a real-world example of this proof of concept to trial to market process?
Yeah, I'll touch on three briefly that you could see here at the show. So the first is the China Mobile example, where they show a complete network anchored originally on Cloud RAN, this idea of a baseband pool and pulling a lot of the intelligence into the edge of the access network, and being able to now, rather than have an asset sit idle as much as 70% of the time, which is the case with base stations today, to reprovision that pool of compute and storage and networking to on-demand capability for multiple applications. So that's an excellent example because they show the Cloud RAN element, but there's also the mobile core that's there, the virtual EPC platforms from 5 market leaders, alcatel-lucent certainly being one of those, but you also see Cisco, you see IBM, you see ZTE, you see Huawei, which demonstrates the fact that the market is indeed moving ahead. So that one for me is one of my favorites because it shows so many elements, not only from moving from proof of concepts to trials, but also commercial availability of solutions. There's a couple of others. SK Telecom is also showing virtual RAN capability, and then we've got Telefonica, who's talking about a virtual CPE platform, and again, an intelligent edge platform for services into the home.
Yeah, I think in general we can see kind of the industry. Last year I felt most of the industry was in the thinking phase, which means all of a sudden NFV was a reality, right? And they tried to understand what does it mean for them, can it work? I think Intel was instrumental there in showing them that network functions can work on top of x86 efficiently. And then they actually created organizations, right? They created an NFV team with an NFV budget and created a roadmap of what they want to virtualize when, and started creating labs which are more commercial labs. And that's where the industry is now. We're involved in 15 such projects right now. And I think what you'll see then is the next phase is actually executing into the market. I think you'll see the innovators in the field with live deployment, not of humongous stacks, but selective applications, maybe ones which less risk, like load balancers, firewalls, DNS, DHCP, easier aspects with less risk on the application, in production this year by some. You'll see a lot more in production next year. This will be limited production, field trials, live users in specific metros. And then 2015 you'll start seeing real scale with a lot more sites and a lot more apps. And we really feel in 2016 already you will see big pieces of the network being built in virtualization, with things like virtual EPC actually being deployed. VoLTE is another big driver we're seeing with the move to LTE. Carriers are now starting to really get serious on moving the voice to voice over LTE using IMS. And there they're going to need to scale up very quickly as more devices come online that support VoLTE.
You mean people still talk on the phone?
People still, we can talk about monetizing voice at a different panel, but definitely it's part of the network for sure, and cloud comes into play there. And we definitely see a few companies. Interestingly enough, this is led by tier ones. In the past we'd see transformation by tier 2s, tier 3 moving first, tier 1s catching up later. In our engagements in Europe, Asia, America, tier 1s are leading, and some tier 1s are at the very forefront and will be in limited production this year.
And I think there's a reason for that, right? The tier 1s are the ones that make the business case for a solution provider like Alcatel-Lucent. No matter how large any one of your individual customers is, it's probably not enough to compel you to build a complete roadmap just for that one customer. When you see at this point in the ETSI 28 global service providers leaning in, establishing a set of requirements, establishing a set of specifications, then leaders like Alcatel-Lucent see a market opportunity that they can embrace versus being uncomfortable with a disruption that's happening. So I think that is key in terms of the tier ones moving forward and really leading that effort. I think the other element of it is really when we look at how you implement a broad participation in the market. The ecosystem enabling element is really critical. Right. How do you invest in, as Dora is describing, labs where they can use as a kind of a playground, right? to figure out what works, what needs to be tuned, what needs to be optimized, what's broken, what is working really exceeding our expectations. That takes investment, but it's collective investment, not only in terms of establishing the lab facility, but for that ecosystem community to come in. And so we have a strong commitment. I mean, it's one of the things that I think Intel does particularly well is ecosystem enabling. We have our own Network Builders ecosystem program. We have 50 members there today. Alcatel-Lucent clearly is one of our strong partners in that effort. And then we also then complement your ecosystem efforts to innovate, right?
Yeah, and we're really proud of that. Our statement in Cloudband is it is a multi-vendor platform, both on the data center and the software stack in the data center. We have one, but you don't have to use it, but mainly in the VNFs on top. So in August, we launched the first ecosystem for NFV and opened it up to everyone, even our competitors. We had 13 ISVs sign up in the first month or two. We're now up to 29 partners, varying partners, small, large, all providing network functions. And for them, they need a runtime environment. They're building virtual network function, but where are you going to test and run it against? You can't go to Amazon and run on a distributed cloud, right? And you can't use the advanced operational tools that we put in place in order to make NFV a reality on an Amazon cloud. So we're seeing that very, very strongly. And in fact, we'll be hosting an event today for the ecosystem with about 30 different ISVs participating, and very, very happy to see the traction there.
Dora, you talked earlier about lifting barriers to entry for the implementation of your technologies, Cloudband, NFV technologies. But of course, operators also have to maintain their quality of experience for their customers. And I know you briefly touched on this, but are you seeing that from operators? What feedback are you getting from them about that process?
So I think the largest barrier we have right now is not a technological barrier, as Sandra said very correctly before. That has been proven. It's about operations and the type of requirements we're seeing. So I mentioned tools we provide for the virtual network functions, but really what's going to matter are tools for the network operations teams at the service providers. Frankly, they're worried. In the current mode of operation, if something's broken, you go to the box, there's a red light on the box, you switch out a line card. It's very clear where the error happened. Here we're talking about many clouds with many layers of abstraction, with multi-tenant applications living all over the place. What happens if something goes wrong? Where did it go wrong? How do you avoid the blame game? And more importantly, how do you fix it? So we're spending actually the majority of our time in 2014, and we just announced our Generation 2 platform, which is the base for that, on operational aspects. Root cause analysis. Where did it go wrong? Automatic healing. How do you upgrade the platform? How to provide tools to upgrade the application? How do you do rollbacks if the upgrade didn't work? Very important. How do you create SLAs? How do you upgrade subcomponents or take data centers offline and allow you to upgrade the kit or upgrade the software there? What happens when servers die, and they will die, and disks die, and they will die? How do you make sure it doesn't affect the applications and they automatically get out of a pool of resources and so on? How do you do capacity management for the shared resources? How do you run what-if analysis in case a site goes down or multiple applications go down? That is what's going to matter in 2014 and where we're spending a lot of our time on.
Yeah. Well, yeah, and I think that, as Dora's describing, a lot of the functionality that you need to enable that type of platform instrumentation, let's call it, the telemetry information that you get from the silicon about power states, about the virtual machine itself, about what is the SLA that you're trying to enforce, what is the policy that in the quality of service that matters to the application at the highest level. And for us, we are continuing to innovate in terms of the silicon features and capabilities that then we expose up to those upper layers in terms of management and orchestration, because at some point it does matter what is under the hood. It does matter if you have crypto and compression and deep packet inspection types of workloads, how you can get that and extract that information from the silicon and the software that's close to the metal, as we like to say. So we continue to innovate on the hardware platform, underneath, and then alcatel-lucent is building on that, where we expose that information and do something useful with it.
Right. I'll give you one practical example. Noisy neighbors. Okay, everything works great when you have one application running on a cloud. But then you have another application which happens to be on the same core and creating a lot of noise. And then Intel technologies like CPU pinning, which can allow us to make sure that the critical application gets a specific part of the CPU uninterrupted by the noisy neighbor, is crucial. Things like getting deterministic performance from the memories for another tool called NUMA, very, very important. And exposing that in a way that's completely abstracted to the end user. So the VNF, all they need to do is say, I need deterministic performance, without figuring out what you need to do to use that is really crucial. And we run the risk, if we don't do this right, to really have deep operational problems in the field without being able to make sure that critical applications get the performance that they need. Being on cloud and using commodity hardware will be commoditized because of NFV, doesn't mean you can't get deterministic performance and high quality experience for the applications or for the end users.
It'd be interesting to see where these cloud-band NFV technologies with Intel architecture go, and we'd like to follow up on that at another event. And just for our viewers, we're getting some complimentary music. We are on the floor at Mobile World Congress. It seems like we're not because we're in a meeting room, but we are, so just so you know. Thanks for talking to us, and again, I'd like to revisit this at a later time.
Be delighted to.
Thank you. And for this program on demand and all of our Mobile World Congress 2014 coverage, please go to tianow.org, and for updates from the event floor, please follow us on Twitter at TIA_now and on Facebook at facebook.com/TIA.now. So long.